It's their first taste of freedom. Researchers are releasing several Przewalski horses into the wild.
It's the only truly wild horse on Earth.
There is a place in northwestern China where the ground does not behave like ground. It does not absorb rain. It does not hold seeds. It does not feed roots. Scientists who visited the Yungar Basin in the early 1980s described walking across its surface as walking across something closer to pavement than soil. The crust had become so compacted, so biologically inert, that water simply ran off it the way it runs off a parking lot. The basin was not dying. It had already died. And it was spreading. Every year through the late 1970s and into the 1980s, satellite images confirmed what ground surveys were already showing. The desert was not staying in one place. It was moving, gobbling up grasslands on its edges, burying roads, collapsing the margins of villages that had existed for generations. Farmers in Xinjiang province watched their fields turn pale and cracked. They watched their wells go shallow. They watched dust carry away the topsoil they had spent their lives tending. The government had tried planting trees, had tried constructing windbreaks, had tried engineering the problem away with money and machinery. Nothing worked. The desert did not negotiate. By 1985, the situation had crossed from crisis into emergency. Agricultural output in the region had dropped dramatically. Dust storms originating in the basin were traveling more than 1,000 miles east and hitting Beijing with walls of grit that turned afternoon skies orange and sent hospital emergency rooms into overdrive with respiratory cases. China was watching one of its own landscapes eat itself alive, and every conventional solution had either failed outright or made things measurably worse. Into this context walked a group of ecologists with a proposal that nearly everyone in the room assumed was a joke. Forget the machines, they said. Forget the tree farms. Bring back the horses. Not domestic horses. Not the kind that pull carts or carry riders or graze in fence paddocks. They were talking about Przewalski's horses, a species so ancient and so genetically distinct from everything humanity has ever domesticated that looking at one feels less like looking at an animal and more like looking at a memory. These horses carry 66 chromosomes. Every domestic horse breed on Earth carries 64. That gap, 2 chromosomes wide, represents an evolutionary divergence that goes back tens of thousands of years. Przewalski's horses were never broken, never bred for human purposes, never shaped by human hands into something more convenient or more obedient. They remained exactly what they had been when early humans were scratching their outlines onto cave walls in France and Spain. They are the original horse, the one the world made before we came along and started editing it. The problem was that by 1985, they barely existed. The entire global population had been reduced to fewer than 1,000 animals, and every single one of those animals was living in a zoo. Wild populations had collapsed across Central Asia through the 20th century under pressure from hunting, habitat loss, and competition with livestock. The last confirmed sighting of a truly wild Przewalski's horse had occurred in Mongolia in 1969. After that, nothing. The species existed in captivity or it did not exist at all. Returning them to the Yungar Basin meant taking animals that had spent 3 and 4 generations eating hay delivered by keepers, drinking from automated water systems, and sleeping in climate-controlled barns, and dropping them into one of the harshest environments on the Asian continent. Winter temperatures in the basin regularly fell below -40 degrees Fahrenheit. Summers baked the ground past 100. The nearest water in some areas sat 15 kilometers away under a crust of ice. Even ecologists who believed in the theory of what these horses could do doubted the animals themselves could survive long enough to do it. In December of 1986, 11 horses stepped off a cargo plane onto the frozen floor of the basin. They had been transported from breeding facilities in Germany and the United States. They stood in the cold, their stocky bodies and upright manes incongruous against the emptiness around them, and the scientists who had arranged their arrival watched from a distance and quietly began calculating how long before disaster forced them to intervene. A documentary crew that had come to record the release packed up and left within days, convinced they were filming a failure in slow motion. Conservation journals were already drafting analyses of why the attempt had been misguided. The horses, meanwhile, were doing something nobody had predicted. Within weeks, even as parasite infections swept through the small herd and temperatures plummeted to historic lows, the horses began behaving in ways their entire captive history gave no explanation for. When standing water froze over, the stallions began striking the ice with their front hooves, cracking through to the liquid water beneath. This behavior had never been documented in any zoo population anywhere in the world. When storms moved across the basin, the mares began arranging themselves into formations around the youngest animals, using their own bodies as windbreaks and rotating positions methodically so that no single animal bore the cold too long. They began pawing through snow with a sweeping motion that uncovered buried grass. They began moving upwind towards slopes where the surface had been swept clear, and downwind away from drifts that would exhaust them to cross. They were reading the land. What the researchers watching through binoculars were witnessing was something that the science of animal behavior still struggles to fully account for. These animals had not learned any of this. Their mothers had not taught them. Their grandmothers had lived their whole lives in zoos. Whatever this knowledge was, it had survived captivity intact, folded somewhere into the biology of the species, waiting for the right conditions to surface. The desert, brutal as it was waking something up that human stewardship had only put to sleep. The horses survived that first winter, not all without cost. Several suffered frostbite. 2 pregnancies were lost to the cold. But the herd came through, and the spring that followed brought the first signs of what would become one of the most closely studied ecological recoveries in modern science. In the areas where the horses had been moving and grazing, the soil was changing. Grass species that researchers had not recorded in the basin for nearly 2 decades were pushing through the surface. This was not a coincidence, and it was not magic. It was mechanics. A Przewalski's horse weighs between 600 and 800 pounds. When one moves at a full run, each hoof strike delivers force comparable to an industrial jackhammer. When 11 horses move across a landscape that has spent years developing a sealed, impermeable crust, they are performing a form of scarification that no human tool has ever managed to replicate at scale. Every hoof print becomes a small depression. Every depression catches rainfall that would otherwise sheet across the hardpan and evaporate. Multiply that by the number of steps a herd takes in a day and across a season, and the arithmetic becomes staggering. In the first year alone, researchers measuring soil moisture in the horses' territory recorded a jump of more than 20%. The rain had not increased. The water table had not shifted. The horses had simply created the conditions for the water that was already falling to stay where it landed instead of running off and vanishing. The second mechanism was movement. Researchers who later fitted the horses with GPS tracking devices discovered that Przewalski's horses do not graze randomly. They cover roughly 15 kilometers a day in patterns that mathematicians have described as fractal, intensively working one area and then moving to another that appears unrelated, then circling back in ways that, over time, create a mosaic of differently grazed zones. Tall grass growing next to short grass, growing next to bare soil, growing next to dense growth creates habitat variety that no single species can produce alone. Each zone type supports different insects. Different insects support different birds. Different birds support different predators. The horses were not just eating. They were engineering a structure. The third mechanism was the least obvious and perhaps the most consequential. Analysis of Przewalski's horse dung found viable seeds for more than 20 plant species in a single sample. The acids in the horse's digestive systems do not destroy seeds. They improve them. The outer coats of many seeds are chemically broken down during digestion in a process called scarification, which dramatically increases germination rates. Seeds that might have remained locked in dormancy for years in the soil germinate more readily after passing through a horse. Studies found germination rates improved by as much as 300% compared to unprocessed seeds. 1 gram of Przewalski's horse dung was found to contain more than 7 viable seedlings. And because the horses were traveling 15 kilometers a day, those seeds were being deposited across an enormous range, reconnecting plant populations that had been isolated from each other for decades. By the early 1990s, the results were impossible to dismiss as noise in the data. Nitrogen levels in the soil had increased substantially. Dung beetles had returned to the basin in enormous numbers, further processing the manure and driving nutrients deeper into the ground. Insect surveys began turning up species that had not been recorded in the region in years. Birds followed the insects. Small mammals followed the birds. By the late 1990s, camera traps set up across the reserve were catching images of foxes, steppe eagles, and wolves moving back into a landscape that had been functionally empty when the horses arrived. In 2001, 15 years after that first cautious release, the project entered its most ambitious phase. 27 horses were released into the full expanse of the Kalameli Nature Reserve, for 1,000 square kilometers of terrain with no fences, no supplemental food, and no safety net. Among them was a stallion the researchers had named Hong, one of the first horses moved into the semi-wild enclosures years earlier, now fully grown and leading his own group. For a week, the horses barely moved from the release point. Then, on the 8th day, Hong began walking north. His group followed. Tracking data showed them covering 30 kilometers in a direct line before stopping at a spring-fed water source that appeared on none of the project's maps. No one had told him it was there. No sensor or instrument had detected it. Whatever cognitive machinery the horse was using to navigate, it was operating on information that human science had not yet found a way to measure. The ecological transformation that followed the full release was documented across multiple independent research programs, and its numbers changed the conversation around desert restoration globally. The water table in the horse's core territory, which had been dropping every year since the 1970s, stabilized in 2003 and then reversed direction. The green zones visible in satellite imagery expanded outward from the horse's territories in patterns researchers described as slow-motion explosions. Plant species that had been absent from the basin for 2 decades were cataloged returning, apparently from seeds that had been lying dormant in the soil for years, waiting for the conditions to change. When ecological economists attempted to assign monetary value to what a single Przewalski's horse contributed to its surrounding environment annually, the figures they produced were not what anyone had anticipated. Soil restoration, seed dispersal, water retention, carbon sequestration, and biodiversity support combined to produce a figure of approximately $47,000 per horse per year in ecosystem services. When those 11 original horses had become more than 500 animals by the 2020s, the cumulative annual value of what the herd was producing for the landscape ran into the tens of millions of dollars. And the desert that had been advancing across the region for decades was, in the zones where the horses roamed, retreating. What happened in the Yungar Basin is not a feel-good story about animals. It is a technical demonstration with enormous implications. China spent billions of dollars and decades of effort trying to stop desertification through tree planting programs, many of which drained water tables faster than the land could recover them. The horses cost a fraction of that, required no maintenance infrastructure, and produced results that trees in that climate could not. They did not need to be managed because they already knew what they were doing. They had been doing it as a species for hundreds of thousands of years before we removed them from the equation. The question that the Yungar Basin forces onto the table is not a comfortable one. The world is full of degraded landscapes. It is full of ecosystems that collapsed after the large animals that had shaped them for millennia were hunted out or driven away. The bison and the American grasslands. The wolves and the river systems of Yellowstone. The elephants and the seed distribution networks of Central Africa. In each case, humans removed the engineer and then spent generations confused about why the landscape kept deteriorating. In each case, science eventually traced the collapse back to the same root cause. We took out the animal that knew how to run the system and replaced it with nothing or with something that could not do the job. The 11 horses that stepped off a cargo plane into a dead desert in 1986 did not save the Yungar Basin because someone made a clever decision. They saved it because evolution had already spent hundreds of thousands of years designing exactly the right tool for exactly that environment. What the scientists in China did was simply remember that the tool existed, and then they had the nerve to use it.